Let's start it. So, problem one states there are nine apparently identical balls, except that one is heavier than the other eight. What is the smallest number of balance scale weighings required to ensure identification of the oddball? So basically, you gotta weigh 4 on 4, and if that's like that doesn't work, then you have to weigh uh the you have to weigh swap out a ball and the. It's the same as we know that the. So let me just do it. Okay, so let's give an example. So basically, what we do is notice that we want to find the number of ways it's divisible by. So say there's 95 identical balls. We want to find the factors of it, which is this 3, 9, 3, and 1. So 9, 3, and 1 share a common factor. And from that common factor, we just make it into groups of 3. Make it easier. Now there's 3 cases to this now. I mean, 2 cases. One, if let's weigh these two. If these two weigh the same, we know that this one's the odd one out, and then we have to weigh one more time. Well, you have to weigh one more time inside one of these to see if they're the same. Like there's gonna be 3 balls, 1, 1, 2 is gonna be the odd one out. So from there, we get that if we weigh these two, we know it's already that one. If we weigh these two and they're not the same, it's gonna be that one. And we know since we know that one's heavier, it has to be heavier, so it gives us the entire answer. Oops. Hold on a second. Sorry. But if we match these two and out and one of them is heavier, we can just use that one the same thing. Same strategy. Problem two states a kitchen pantry, so we get basically the answer is gonna be E. A kitchen pantry has 5 shelves, each containing a specific kind of food. The spices are on the shelf directly below the vegetables. The fruits are above the bread, and the vegetables are 3 shelves below the cereals. Which kind of food is on the third shelf? So, spices are below vegetables. Vegetables are 3 below cereal. So then we can figure out. From there, we can figure out that we can let me just basically make them by the first name. So vegetables is known as V, fruit as F, cereals as C, then spices as S, and B as bread. So we're gonna be looking at this. Spices, V, and then cereal. So this is a random shelf cereal. Notice that that's already 5 shelves. This one encompasses 1 shelf, 2 shelves, 3 shelves, 4 shelves, 5 shelves. So C, V, and S. It has to be like that. There's 3 shelves below. So this one's 1, 2, 3. So it means that the fruits are above the bread means fruits are and bread is over here. So it means 2 is C or bread. So just picturing it gives you the answer. Now, I hope middle school, Mr. I, Mr. Love, and Mr. Problems teach science, mathematics, and history, but not necessarily in that order. The history teacher, who was only a child, has the least experience. Mr. Problems who married Mr. I's sister, has more experience than the science teacher. Who teaches science? So the history teacher is only a child, which is logically we know that Mr. Problems is not the science teacher, but Mr. Problems also isn't the history teacher, I'm pretty sure. Because the history teacher, because Mr. Problems already married, and you're not gonna marry when like 10 years old, something like that. But anyways, it means that Mr. Problems is mathematics. Mr. P math. And from there, we get that Mr. P has math, then Mr. Love and Mr. I. Mr. I is definitely not the youngest. So he's not the his no, Mr. P is math and Mr. I has to be science because Mr. I is not the youngest because Mr. I's sister marries Mr. P, meaning that Mr. I is not that young. He's not a child. So it means Mr. I is teaching science. Problem 4. 5 coins look the same, but one is a counterfeit coin with a different weight than each of the 4 genuine coins. Using a balance scale, what is the least number of weightings needed to ensure that in every case the counterfeit coin is found and is shown to be heavier or lighter? First of all, we just split this A, B, and C. A, B, and C. It's actually 2 coins there, 2 coins here, 1 coin there. This gives us basically they were the same, the coin E is the counter rate A and B. If they were the same, then E is the counterfeit coin. Then we get that. So then we get that if A and B are rated to be equal, what if Mr. I is the small sister? Mr. I doesn't have the small has a small Mr. I has a sister or small sister, it doesn't really matter, I don't know. But let's just take it to a general approach. Okay. So let's go on back to problem 4. Uh C if 1 is a counterfeit coin. If C is the counterfeit coin, these are gonna be weighed the same, so it means C is the counterfeit. If we weigh this and 1 is different, we just weigh those two. It gives us two, but then we don't know if it's like basically we don't know if the heavier or lighter, so we have to weigh one more time just to get a 3. A centipede climbs a 40-foot tree. Each day he climbs 5 feet, and each night he slides down 2 feet. In how many days will the centipede reach the top of the tree? Basically, we go from 40, this the total 40 feet, and as we talked in the last lesson, you go up 5 feet, you go down 2 feet every single time. But once you reach the top, say you're on the you're 35 feet above the tree, above the ground on the tree. If you go up 5 feet, you're not going to go back down 2 feet because you already reached the top. There's no way you're going to go back down. So from there, we know that. What's your question?
No, just asking. Is 13 the right answer?
13. Hold on, let me see. Yeah, it's 13.
Okay, thank you.
So basically, you just go from basically every time you go up 3. So 3, 3, 3, 3, 3. So how many days? Well, let's do some math. We just do 40 minus 3, 5. Gives us 35. So that's the minimum number of days it has to reach in order to get above the tree. Now, the first multiple that comes up is going to be 36. It happens on the 12th day. Now, you can't reach 35, so you have to reach 36. Because if it's 33 on the 11th day, goes up 3 and now on the 12th day. The 13th day is going to go up 5, which gives us 41, which means he reached already the top of the tree, meaning it has to be at least 13 days in order to reach the top of the tree. Problem 6 is Adam, Ben, Charles, and David and Ed are waiting in line. Adam is behind Ben and Chase. Ben is behind David and Adam. Ed is also between David and Adam. Ben is between David and Ed. Who's in the middle of the line? I'll let you guys have a try on it and tell me the answer to the chat. What's your question?
Just asking, like, for the chat, it says to teacher, but like, there's supposed to be a drop down menu, but like, I can't change it to everyone.
Yeah, because before there's like problems with the chat, we'll say. What's your question?
Um, so they don't tell us which order they're in, like if like Ben and Adam, David and Ed are like in front of Ben, Adam, and the other one. It doesn't tell us if it's front or back.
It tells you the relative placements of where they are.
Oh, okay.
It wants you to find out the placements, they're not going to tell you where they are.
Okay.
What's your question?
Oh, so basically, is the answer? Wait, do I say the answer? Because I got it.
You say it through the chat.
Oh, okay.
What's your question?
So like, how come? How can Adam be between Ben and Chase? And no, how come Ben is between David and Adam, but Ed is also between David and Adam? Does that mean Ben is like one near Ed, or but like does between mean like
Okay,
they
so
between?
basically, so we know that let's let them be A, B, C, D, and E. Basically, A is between B and C. We don't know what's between them. But we also know that B is between A and D. We know it can either be this case or that case scenario. It's also between D and or is it this way? Doesn't really know. But he's also between Adam, David, and Adam, which means someone else is over here also, and someone else is over here. And Ben is between Ed and David, meaning it's either this configuration or this configuration. Which is still meaning that Ed is the middle. So nice job for the people who got it right. What's your question? What's your question, A?
So that I forgot to type in my answers. It's E. Also, why is Charles became Chase? Is this a like a
It's probably not consistent. It's a problem writing problem error.
coincidence, or is there 6 people?
No, it's probably an error. Sorry, it's probably an error. What's your question?
So basically, I can't really read that. Is it like CAEDB? Oh no, CAEBD.
No, there's two. Those are the.
I know the answer is E, but is the one next to EB?
Yes.
Oh, okay.
You could ask your questions to chat, not to unclog. Okay, so let's move on to the next question. Five cards are lying on the table as shown. Each card has a letter on one side and a whole number on the other side. Jane said if a vowel is on one side of any card, then an even number is on the other side. Mary shows Jane was wrong by turning over one card. Which card did Mary turn over? Tell me your answers to chat. Feel free to ask questions also to the chat.
Can I try to answer the
What's your
question?
question? Can you say it again?
Can I try asking? Can I try answer the question again, please?
You wanna do what?
I try again.
Sure. Let me make it clear. So basically, what they're saying is basically depends on the order. So this one's gonna be card one. There. 1, 2, 3, 4, 5. Basically, it should be like that. So let's go over it. So basically, we wanna first try to verify the statement. If a vowel is on one side of any card, even numbers on the other side of the card. So there isn't really any vowels. We have 0 cards to turn over. But now we discussed in last lesson that the basically the original statement is equal to the contrapositive. You don't understand what was the contrapositive? The contrapositive was basically if we said if P then Q was the statement, then the contrapositive is basically, sorry, my handwriting is messing. He said, if not Q, then not P. Or in other words, every card that does not have an even number on one side does not have a vowel on the other side. So we want to find the even card. So it can be 2 or 3. But we also want to turn over a composite card. So the best example would be 6. Yeah, but these two are the same, but we must turn over any card with a composite number. The only to make sure that it doesn't have a vowel on the other side. So basically it could be C or D, technically. I mean, yeah, basically 2 or 3. Okay. Go on problem 8. Centipede is close up a 75-inch tree. Tree 75 inches high, starting from the ground. I said 6 and 4 both work. Anyways, a centipede crawls a tree 75 inches high, starting from the ground. Each day crawls 5 inches and each night slides down 4 inches. When will we first reach the top of the tree? Tell me your answers for chat and feel free to ask questions. So it's not A. It's also not C. Well then,
Question. Is a night the second day, or like are they the same day, or are they two separate days?
can you say it again?
So it says each night it slides down 4. Is a day and a night a different day?
No, it's the same.
Okay.
What's your question?
So if you don't know that when it's 12 o'clock, which is midnight at night,
is actually the next day. So technically, it's actually continued, I think, right? Okay, so let's get started with this question. So basically, a centipede crawls 75 inches high. So every day we talked about it, it goes up 1 inch, technically. We go up 1 inch every single time. And from there, we basically go up 1 inch every single day. So for these entire days, go one up 1 inch. So 71 days because we want to reach 5, but that's impossible. So 75 plus, so we want to make a 70. So let me talk about it. I'm saying it more clear. So basically, we want to make up every single time. So if we get up to 75, that's when we get up to 70. But 70 is the 70th day. So if we get to the 70th day, we cross 70 days, we each gain 1 inch every single day in those 70 days. Now on the 71st day, we plus 70 plus 5 more, gives us 75. Or gives us E, 71 as our answer. Why? Because we go 70 days. For 70 days, we go up 1 inch. So on the 5th day, on the 71st day, we go 5 inches and we don't go. So to clarify things up, the day and the night are the same. They're basically saying the morning to afternoon to the night and midnight in that time period. Or maybe 12 a.m. to 12 p.m. Or no, probably say it's like 6 to 6 p.m. And then basically from there, basically. So let's move on. From example 13. So I'll let you guys have a try on this problem and tell me your questions through chat and your answers. The question?
So so like right now I'm taking notes. So like how would you write this one? Cause like I got the answer, cause like a person's not accusing someone else. They're saying that someone lied. So I have a question, how would you write down the solution?
So what did you get?
Dean, because he said Bob lied and Bob said Dean did it.
Okay.
It's kind of a guess.
So why is it he?
Because like Alex is accusing Bob and Bob is accusing Dean. Cam said I didn't do it. No one accused Cam. But then Dean said Bob lied. So if Bob lied, he's only saying probably like saying Bob lied because like Dean did it. So he's saying Bob lied to cover himself.
So far A got it right. So but it's not Dean.
All right, hold up.
What's your question?
Never mind. I was just asking a question like chat.
Okay. So it is Cam. It's indeed Cam. So why is that? Let's go step by step. Alex says Bob did it, and Bob says Dean did it. and then Dean said Bob lied. So if Bob says the truth, then Dean is lying, which means that Dean did it. Cam is saying the truth also. I didn't do it. And also, but Alex is also saying Cam is basically saying the truth. So one of them is saying the truth. So if Bob didn't do it, that's a false. That's also false. But then this is true. So this is impossible. So if Dean says Bob lied, then Dean didn't do it, or Bob, and then so Bob didn't do it, and then Cam is lying. So it says Cam did do it, and from there you see that nothing is contradiction. So it gives us Cam as the answer. So Dean told the truth. I mean, yeah, basically Dean told the truth, and Alex and Bob and Cam did not say the truth. So it'd be Cam. Now, problem 14, example 14, a sealed envelope contains a card with a single digit on it. 3 of the following statements are true, and the other is false. The digit is 1, the digit is not 2, the digit is 3, the digit is not 4. Tell me your answers to chat, and feel free to ask questions also.
What does which one of the following must necessarily be correct mean?
Say it again, please.
What does which one of the following must necessarily be correct mean?
Means which one has to be right. Like, no matter what, which ones are false or which ones are true, this one will always constantly be right, basically.
Okay. Thank you.
What's your question?
So wouldn't it be like two or no, I mean 1 or 3 because the
Please
digit
tell
one.
it through chat and I'll talk about it.
Okay.
So it seems like 1, 2, and 3 people so far got it. So, because it's accusing something that is not there. So, basically, let me go over the problem list first off. So basically, there's 3 of the following statements are true and the other one's false. So let's take it case by case. Case by case. it did, let's say 4 was false. Then the digit is 3, the digit is not 2, and the digit is 1. So these are contradicting. So we need that the digit is not 2. If statement 3 is false, that means that the digit is indeed not 4, not 2, so the digit is indeed 1. This works out. And without using case work, you can see from this, there are two possible. The digit is not 4, and the digit is not 2. So I'm saying that the digit is not 2 is necessarily correct. And from there, we don't see a 4 is false. We don't see a 4 is true, so it means that C or 2 must be true. What's your question?
So I'm like, could you wait a little longer? Because I have to write down the whole thing. Because could
Okay.
you rewatch the video?
Yeah, you can watch the playback.
Oh, okay, thank you.
Okay. So let's move on to problem 15. Down there. It's basically the exact same method. This one really should be quite easy now these days. So now I'll let you guys have a try, and I'll give you like 2 minutes to solve this. What's the question?
Uh, uh, I I think this means I think I know the answer. Also, can you uh tell me if my answer is wrong in the chat, please? Thank you.
Sure. So the answer in this case is going to be A, or 19. Sorry. So would you subtract 3 from 5 because it is the same day? Yes, every single day you do that. Except when you reach the 40 feet tree mark. Basically, you go up 5 for one day. You go up 5. And then the night, you're going to go back down 3. Tomorrow, you're going to go up 5. And then at night, it's going to be 3. That's going to be a 19. From there, we go up every single day. But notice we want it so it reaches 35 or above, because from there it's gonna be obvious that it's gonna go past the mark or just meet the mark, and you don't have to go back down anymore. So from there, you subtract 5, which gives us 35. So we want it to be at least at 35. Since we're going up 2 every single day, the least possible one is gonna be 36, or the 18th day. The 18th day you reach 36. So the 19th day, the next day, is going to be plus 5, which gives us 40. I mean, plus 5, so 36 gives us 41, actually. Which gives us A as 19, because it reaches past the 40 feet mark. So let's go move on to example 16. Alex has 6 coins. 5 of the 6 coins weigh the same, and 1 coin is heavier If Alex had a balance scale, what is the least number of times he could weigh coins to be sure he could determine which coin was heavier? I'll let you guys have a try in the chat and tell me your answers through chat. What's your question?
So is every coin like one one way, or is like the two coins, or the two coins equals one way? Because on a balance scale, you need two stuff.
Yeah, you have to weigh the two stuff.
Yeah, so would you just like if you weigh two coins on those, would that equal a one?
Basically, if you want to, it depends on what you weigh. So basically, what we're supposed to do in this question, it's not 4, it's 2. So basically, 5 to 6 coins, we can just split into A and B. Those are groups A and B. Each group has 3 coins. Group A has some random coins in those bag. This one has another random coin in that bag. Now we're gonna weigh it. Put that as a weight. There. You're weighing this back. And since you weigh this back, you want to see which one's heavy because we know if it's heavier or low or smaller, lower. Because we know the counterfeit coin is going to be heavier. We want to look at the heavier one. Because let's say B is the heavier one. If B is the heavier one, we can just weigh one on one. If we weigh the one on the same, it means the other one. So if these two are equal, that means this one is the odd one out. If these two are different, then we can see that this one is also odd one out because we want to look at the heavier one. So the answer is gonna be 2 in this case. Okay? Let's go on to problem 17. In a horse race game on a computer, secretariat, man of war, affirmed, and citation finished in first through fourth place. Not necessarily in that order with no ties. Man of war finished second or fourth. Affirmed did not win the race. Citation or secretariat finished third. Man of war beat secretariat. What is the name of the horse that finished fourth? What's the question?
So could you go back to like the first problem where we had to do like the 6 coins, 5 heavy? I just want to check something.
Oh, this one?
No, like the last one we did. That was like it's like before that one. Yeah, this
Problem 4?
yes. Oh, hold on, no, not this one. It's kind of like the 6 coins and 5 is the same weight and one's heavier. It's like that. Oh, it's that first one up there.
Which one?
Like the very first one we did.
Problem 1?
Yeah. Oh, thank you. Oh, okay, thank you.
Okay, let's go back. As you guys haven't tried it, tell me your answer to the chat. Seems like most of you get it now. It's basically affirmed. Okay. So basically, how you're supposed to do this question is basically notice that if man of war is fourth, it means that man of war cannot beat the secretariat because he's in last place. So man of war, well, M is in front of S or secretariat, which finished third. It means that citation has to finish fourth. I mean, citation cannot finish fourth because affirmed is not first place. So affirmed is going to be last place and citation is going to be in first place. So it's going to be A or affirmed. So move on to example 18. Below are 4 labeled boxes. Each box is painted a different color. There's a red, which is next to blue. There's a green, which is next to red and yellow. Which box could be painted red? Tell me your answers to chat. And I'll answer questions also in chat. What's your question?
So for the last problem, who got first? Because like, how can Man of War affirmed Citation and the guy who has an S in his name all finish in the last 3 spots? Because who won?
Citation one.
Oh, okay.
What's your question?
So if it was in a line, it would be in my calculations impossible because if there's a red box which is next to a blue box,
You gotta put
and
that through chat. And then basically tell me your answer through chat.
would it be in the line though?
Which one?
18, would it be in the line? Would the boxes be in a line?
Yeah, basically.
Okay.
They're in a line and we just want to find which ones is what color.
Because all of them are red next to the red box. So
Not technically. What's your question?
Excuse me, could you like go back to the horses problem for like 5 seconds?
Okay. Tell me when you're done, okay?
Wait, wait, I was saying like, could you like go back to the horses problem for like 5 seconds?
不，你得给他口香糖，对不对？
Uh, huh?
Are we good now?
I only see question 18.
Oh, sure. Well, over there. Are you good?
Okay, thank you. Okay, can you catch up? I'm done.
Okay. So now let's click on example 18. So it says red is next to blue, red is also next to green, but not next to the yellow box. But green is also next to red and yellow. So this is what I'm kind of thinking. Maybe it could be like this. So it has to be 2 or 3. It has to be in the middle. Why? Because it has to be next to at least like it has to be next to two colors. Yeah, it's not only next to one color. See, red has to be next to blue and also next to green. And then blue is next to only one box with red. It generally says that. And uh, green is next to red, which is also next to yellow. So these are basically 2 and 3. So there's only 2 cases, which gives us D as our answer, or 2 or 3. What's your question?
So basically, so like so green is next to red and yellow, right?
Yes.
So and red is also next to blue. So red is sandwiched between blue and green, and yellow has to be next to green. So how is it D? How could number 3 be green though?
Okay. Let's see.
I mean number 3 be red.
Number 3 D red. Let's try this out. R
Oh
G
wait, hold on. I just
Y. Like that order. Can you see it?
yes. Okay, thank you.
Okay. So let's now tackle problem 19. This is example 19, which is in an AMC8 question. Amy, Bill, Celine are friends from different ages. Exactly one of the following statements is true. They didn't write it. So basically, these are the 5 statements I'll write for you. Number 3, Bill is the oldest. 2, Amy is not the oldest. 3, Celine is not the youngest. And then, so rank the friends from oldest to youngest. Uh, just let Amy be A. Let this person be A. B as Bill, C as Celine to make it easier. I'll let you guys have a try and tell me your answers to chat. Okay, so basically how we're supposed to do this is basically from starting, we basically know Bill who's the oldest. So if B is the oldest, then Amy is the oldest, which is false. So these two contradict each other. But if Amy is not the oldest, it's true. It means that Bill is indeed the oldest. It means that she is the youngest. So B and A and C. But that doesn't quite. But hold on a second. But B is not the oldest also. So it has to be A is not the oldest doesn't work because B and A are both not the oldest then. And then C is also not the oldest. So you can't find anything in there. So the third statement must be true. So it means Sydney is not the youngest. And Amy means that Amy is the oldest, so it's A. Bill is not the oldest. And she is not the youngest. From there, the opposite of Bill being the oldest is Bill the youngest. So it'll be A, C, and B. So their answer is gonna be A, C, and B. What's your question?
So like, but like, who is speaking the truth? Because like, if like the Roman numeral number 2 was speaking the truth, then it would work. But like, if the Roman numeral number 3 was also speaking the truth, then it will also work.
So basically, so let's try B again. So if Bill is the youngest, we get the Celine's also youngest. Which means both these two are not right. So they're basically contradicting. Same with Amy. If Amy is not the oldest, then Bill has to be the youngest. And so is Celine is also the youngest. So these two contradict each other. So the only possible one is ACB or Amy, Bill, and Celine. Okay? AMC8. So this is example 20. You barely have any time left. So I'll guys give you a brief overview, and then we're gonna solve it in the next session. So 5 friends compete in a dart throwing contest. Each one has 2 darts to throw at the same circular target. Each individual scores is the sum in the scores in the target regions that are hit. The scores of the for the target regions are the four whole numbers from 1 to 10. Each throw hits the target in a region with a different value. Scores are Alice 16 points, Ben is 4 points, Cindy 7 points, Dave is 11 points, Ollie 17 points. Who hits the region with 6 points? Others guys have a time, but it's ready time. It's 8 o'clock, so the session is gonna be over. So I wish you have a good night, and I'll see you in the next session. Bye. Also try to think about this problem while we're not in the session. Bye. Have a good day.